Okay, we are going to do for B 1, 2, 5, and 6. So this is about histograms and averages. Below are sketches of histograms from 3 lists. The answers for the average could be 25, 40, 50, 60, or 75. What is the average of A? 50. For B, 25, and C, it's probably 40. And C is the hardest one. So it kind of looks like this. Yeah, I didn't do that very well. Okay, it looks like that. And we have 25, 50. I'm not very good at drawing these, huh? 75 and 100. Okay. We want to find where is this picture balanced? Where does the left side and the right equal the right side? That looks better, right? And it's going to be about right here, if I would have drawn it correctly. So this area is equal to this area. Oh, I turned the page apparently. And then number 2, for each histogram, is the median equal to the average, or is it left or right? So for A, how does the median compare to the mean? They're in exactly the same place. How come? Why is that? What is it about that graph that tells us that the median and the mean are going to be in the same place? It's symmetric. The right side and the left side look exactly the same. Okay, what about in B? They're going to be the same. And C, what is it going to be? The median is left of the mean. How come? So this one is the average, and the mean, or the median, is going to be to the left. The median divides the people into 2 equal groups. Okay, but the mean distributes the weight evenly among all of the people. Remember our gummy bear story? The median cuts the people into 2 equal groups. A group that has lots of gummy bears and a group that doesn't have as many gummy bears. But the median, or sorry, the mean goes through and grabs everybody's gummy bears, puts them in a pot, and then redistributes them evenly. So the people that weigh more affect the average more than the people who don't. So the fact that this has a right tail pushes the mean or the average from the median to the right. Because whoever is 100 years old, they have more of an effect on the graph than the people who are 60 years old, because they weigh more. Not physically weigh more, right? But that 100 is worth more to the average than the numbers left of it. All right, number 5. For registered students at universities in the U.S., which is larger, average age or median age? Let's throw it in there. Average age or median age? What is the graph going to look like for people registered at universities? So, how old are people that go to universities? What's the low end? 18. What do you think the high end would be? Is there anybody over 30 going to college? Yeah. So maybe 40, 50, 60. Some people go to college for fun when they get old. So I'm going to say 65. Okay? Now, where is most of the area going to be? To the left, between the ages of 18 and 30. Is it? Well, Which age do you think will have the most? 18, 19, 20, right? What's going to happen after 20? Some people drop out, some people graduate. So it would probably look something like this. Right? With most of the people, and I didn't draw this very well, right? That 65 should probably be like way out here. Almost nobody over there. And then the bulk of it is going to probably be between maybe 18 and 21. Okay, some people don't go straight into college, so they might not be 18. So I would guess that like 19 or 20 would be the highest point. Right? Some people wait a year to go, and some people go a year and drop out, and it kind of evens out. So, where would you put the median? Probably about right here. Maybe to the right just a little bit. Okay? The group of people between 18 and 21 is equal in size to the group of people between 21 and 65. Where would you put the average age? To the right of that. How come? Okay, this is the average. And the reason is, if there is anyone out here, they are really going to mess up the average. Do you remember when we talked about income for selling security systems? The one guy who made a lot of money pulled the average that direction. Didn't change the median at all, but it does pull. If you add somebody to the, well, if you add somebody to the right, the median moves one number, or half a number, I guess. Does that make sense? You have a group of people, you add two people to the right, the median will move one number to the right, one person to the right. But if those people weigh a lot, then the average is really going to slide that direction. Okay, and number, what was the last one? 8? Nope, 6. For each of the following listed numbers, say whether the entries are on the whole around 1, 5, or 10 in size. So A would be 1. They're all about 1. They're close to 1. B, 10, C, 5, and D, 5. Okay? We kind of ignored the negatives, right? No, but it'll make more sense in a little bit when we do the next set.